This is a self-excited charging system. A charging system incorporating a self-excited alternator. The major components of the charging system are as indicated on the diagram. We are now familiar with the major components, but maybe we can just have a quick rundown of these major components and their functions. The rotor is the major component of the alternator. It is the electromagnet. Within it, there is an inductive winding whose function is to create a magnetic field, which is going to be applied for the purposes of inducing voltage and current in the stator. The rotor, of course, is the belt driven from the crankshaft. Then there is a stator. The stator has got three phases with three windings that are wound, in this case, in this diagram, the three windings are wound in what we refer to as a star form. There's another alternative way of winding these, we call it the delta winding. This central point, we call it the neutral static point. And the other loose ends are the outputs, which are then going to be connected to the rectifier. The purpose of the stator is to induce voltage and current using the magnetic field of the rotor. Within the stator, the magnetic field, the current produced is in the form of alternating current. And alternating current is produced, which is not suitable. The alternating current is not suitable for motor vehicle applications, and hence the need for a rectifier. We refer to this as the bridge circuit for full-wave rectification, and it normally consists of, probably depending on the type of alternator, a minimum of 6 diodes. In this case, we have 9 diodes. We can even have up to 11 diodes, like as is in the case of this type of rectifier. This type of rectifier has got 11 diodes. Of the diodes that we have in this rectifier, 1, 2, 3 diodes, these are negative diodes because they are connected to ground. 1, 2, 3, these are positive diodes because they are connected directly to the battery. So the output from the alternator is transmitted to the battery for recharging the rest of the motor vehicle via the positive diodes. Then these are the excited diodes. These diodes are dedicated to the collection of what? Of current and directing it to the regulator and the rotor for continued excitation for the alternator to continue to charge. So we call them excited diodes. Excitation, I think we have explained. The process of excitation is rather all about connecting current to the rotor in order to create a magnetic field, which is then going to be applied to the task of generating voltage and current within the stator windings. We have a Zener diode. We call this a surge protection diode. The purpose of this diode is to protect the rest of the system from such an electric surges that can happen in the event of a short. In the event of a short, a high voltage produced by the alternator is going to be damped to ground by a Zener diode. So in fact, it's a damping device. It damps excess voltage generated here due to a fault in order to protect the regulator and other electronic devices of the motor vehicle. Then we also have a diode across the warning light. The warning light diode is just a precaution against undercharging in the event of the failure of the warning light itself. It provides an alternative path for current to flow to the regulator and the rotor in the event of this warning light blowing up, because the warning light provides a path for current to go to the rotor for initial excitation. Then, of course, we have the battery. The battery is there to store the voltage generated by the alternator. Then the regulator controls alternator output to prevent overcharging. I'm sure we are quite aware of that, we're familiar with that fact. Then the ignition switch is for controlling, switching on and off. Now let's explain the operating principle, the process itself. What actually takes place for the alternator to produce an output from the beginning to the end. When the ignition switch is turned to the on position, current flows through the warning light, regulator, motor to ground. This creates initial magnetic field. We refer to this as initial excitation, and this is what we refer to as battery excitation. The current coming from the battery, controlled by the ignition switch, is applied to the rotor to create the initial magnetic field, which is going to be applied to the stator for the alternator to start charging. Then when the switch is turned to the start position, we crank the engine, and the engine is now running. The rotor will now be spinning. With the spinning rotor inside the stator, our rotor is spinning inside the stator. With the rotor spinning inside the stator, fulfilling the requirements for induction to take place. With induction taking place, that is the rotor rotating inside the stator, an EMF, the voltage and current, are produced. And the voltage and current are in the form of AC. They are then transmitted to the rectifier, which then converts the AC to DC in order to recharge the battery, and in order to supply all other components requiring power when the engine is running. In this case, the two outputs, one from the exciter diodes, are applied on both sides of the warning light. Like what you are saying is 14.2 volts is applied on this side of the warning light by the exciter diodes. Then 14.2 volts is also applied on the other side by the main diodes. This as a result will then short out. The warning light, and the warning light will go out. That the going out of the warning light is a signal to indicate that the alternator is producing an output above that of the battery. In the event of undercharging, with the zero output from the exciter diodes, zero output from the main diodes, we are only left with the battery's output to flow through the warning light, regulator, and ground. So as a result, the warning light will stay on with the engine running to indicate to the driver that the battery is, rather the alternator is under charge. We can switch over here.